Good evening. We are the group who will install temperature measuring apparatus on the air compressor, test rig, and mini plant. I am Nelson Jhan M. Alcantara, and these are my group mates.
I am John Jose who will describe to you the LM35 temperature sensor.
Jhan and I will explain and demonstrate the temperature sensor, the difference between the actual and the Arduino reading.
First of all, I would like to introduce the air compressor test rig and mini plant. The air compressor test rig and mini plant is used to measure the volumetric efficiency of an air compressor. Now, the researchers will try to make a temperature sensing device in order to measure the temperature at various points in the air compressor test rig and mini plant. The researchers will install DS18B20 temperature sensors at T1 before entering the heat exchanger system, and at T4, which is the pipe after the heat exchanger system. Currently the temperature sensor used in making the temperature apparatus is an LM35 sensor. LM35 is temperature sensor which has an output voltage linearly proportional to the centigrade temperature. LM35 sensor has an accuracy of positive and negative 0.5 and has an operating temperatures of negative 55 degrees Celsius to 150 degrees Celsius. The next step in this presentation is to how the LM35 will be used in the Arduino using the equation generated from the Excel.
Good evening, I am Andrew Maglana and I will explain the program that we use in order to calibrate the LM35 and use it for instrumentation. The circuit is made like this. The resistor is connected to the ground of the LM35 and the program pin. The ground is then connected to the ground port of the Arduino, and then the data from LM35 is connected to analog pin 0. The 5 volts or Vin of LM35 is then connected to 5 volts of Arduino. Program that we use in our instrumentation. First, the float function or float language. It is used to define a variable with a fractional value. Then next is the integer or int, used for initiating declaration of a function. Void, used to refrain anything from returning from a function, or in short, there is no return. The delay, used to suspend execution of a program for a particular time. The scale factor is 1 second is equals to 1000 millisecond. Serial begin. It is used to set the data rate in bits per second for serial data transmission. Serial print, used to print data to the serial port as human readable text. Open brace. It signifies the beginning of a main function. And lastly, closing brace, end of main function. There are also some here that indicates the equation that is used in the program. Instrumentation, we have come up with these equations. Equation A. The 1023 that can be seen here is the maximum memory, or the memory that our Arduino can read. And the 0.05 here is the percentage error that our LM35 has, that it is found in the datasheet of LM35. After computing for A, variable A, we then move to computing variable B, which is 1023 minus A. From then, we go in creating variable C, which is 5000 over B. 5000 here is the voltage in, or Vs, of LM35, which is 5 volts converted into millivolts. This equation is the ratio of voltage over the memory. Tama ba? Pwede na. The equation here is the ratio of voltage over the maximum memory, or memory that the Arduino read, minus its error. After coming up from this equation, we can then come up for the equation for the volts. Since we have computed the ratio of voltage over the memory with its error, we can multiply it to the memory that our Arduino can read from our LM35. It is then the voltage that is across LM35, or our sensor. With it, since in the datasheet of LM35, it is stated that 10 millivolts is equals to 1 degree Celsius. And so we have come up to the equation of temperature is equals to voltage over 10. After our experiment, we have come up with this data. And then, with this data, we were able to get these equations. This equation is for computing voltage. And then this one is for computing the temperature. With this two equation, we were able to put it in our another program. And so we came up with this program and set of equations. With this, we gathered this data. And computed for the design error for the temperature and the voltage.
We'll demonstrate that the equation we have created were right using the infrared thermometer and DMM to help us calibrate the LM35. I and Jessie will use the LM35 using the program we created. We have 8 trials to be able to come up with our equation. We can demonstrate 2 of the particular place inside this house. This time, we will check our LM35 if the calibration is correct. Here, we are inside the room without air condition. as you can see, the reading in the DMM is 285, and our reading on the Arduino is 283. Reading in the infrared thermometer is 30 Celsius, and in our Arduino, in the serial monitor, the reading is 29.36. So we can conclude that our program is correct.
For our second trial, we will be sensing the temperature of the exhaust fan of a laptop. So the infrared reading is 35.3 degrees Celsius, and the reading in our Arduino is 35.35 degrees Celsius with 353.7 millivolts. The reading in our circuit is 353.2 millivolts.
To conclude our calibration of our LM35, we can say that the equation generated by our Excel file is correct or about the same with the reading that we can get from the infrared thermometer and the DMM.
Thank you for watching our video.